Ooh, that's a lovely looking day.
And if you haven't by this time, click that subscribe button. Appreciate it.
Alright, so now that I have all of the machines where it needs to be, I'm going to go ahead and run all of the ductwork from the dust collection system that you see right there. So we're going to run all the pipes from the dust collection system to the jointer, the planer, and to the table saw. You can use Schedule 40 PVC pipe, or you can use metal duct. I'm using SDR 35 because in my area it's a little bit cheaper than Schedule 40 pipe.
The first thing that I need to do is determine the initial connection point from the dust collection system to the various duct runs. Because the layout of my shop, the most efficient location for my dust collector was sort of in the back corner. This is pretty much the central point where it connects and branches out to everything else. This would limit the amount of duct runs that I need to connect to the various tools. But because of the location where I'm putting it in, I need to run a 8-inch flex hose to allow for some movability so that I can access the back of the dust collector and clean it out if I ever need to. Cutting PVC is perfectly fine on the miter saw. You just have to let the blade get up to speed before making the cut. I'll show you a little bit later what happens when you don't. It helps to assemble portions of the duct run on the ground first before installing it onto the wall. Even though this is a pretty thin PVC pipe, it can get pretty heavy once you have multiple components connected together. Once I got the largest pipe secured onto the wall using steel hanger straps, I went ahead and continued the remaining lines and got everything taped together. I couldn't find an SDR reducer that went from 6 to 5 inches, so I went ahead and used this metal reducer instead. It's the only metal reducer that I'll use in the entire system. What you'll have to do is you have to tape the seams because it doesn't really fit well with the SDR pipe, and once you tape the seam, it should seal it up nice and good. Alright, so this is where things went wrong. As I mentioned before, it's perfectly fine to cut PVC on a miter saw, but you gotta let the blade get up to speed before you make the cut. And I have done that in previous cuts, but at the very end I was rushing and, well, I'll let you see what happens. Yeah, that was really scary. Now, I do take precautions and make sure that everything is done safely and according to plan, but sometimes these things do happen. You just have to learn from it, move on, and use a jigsaw. After that, everything was smooth, thank goodness. I did have one light in the way, so I simply took the light off and reinstalled it once all of the pipes were installed in the ceiling. Again, this pipe could be pretty heavy, so what I did was installed one pipe strap and use it as leverage to hold up the pipe as I went to the opposite end to secure it with another pipe strap. I'll explain this a little bit more later in the video, but the fittings that I purchased came with a gasket that was supposed to help seal the pipes together. Even after I used lubricant to help force the pipe into the fitting, it was a real pain in the butt to work with. So I ended up removing all the gaskets altogether and then went back and sealed all the connections with metal duct tape. This connection here goes to my bandsaw. I know it looks pretty weird, but I'm going to rework it later on to make it look a little bit better and not have such a sharp turn. The remaining runs were pretty much redundant. I simply just measured, cut the pipe to the right length, and then secured it with the straps. Once I got all the pipes installed, I went ahead and connected the tools to the dust collection system by using flexible hose. And I'm limiting myself to 5 foot of flexible hose for any of the connection points to the actual tool.
Alright, it's been about a week and a half or so since I finished installing all of the ductwork for my dust collection system. Over the course of that week and a half, I was able to get some projects done in the garage and just to test out the ductwork, see if I needed to make any adjustments, if there was any leaks or anything like that. So far, everything has been great. For the remaining portion of the video, I'm going to give you an overview of my dust collection system, where the connections are at, a little bit of reasoning behind why I chose SDR35 pipe instead of metal or flexible hose. And for the geeks out there, I'll go over some of my CFM numbers just so you're happy. I want to go over the kind of idea of why I chose SDR35 pipe over some of the other materials that are out there in the market. The first material we typically see inside small shop is this. This is flexible hose. You pretty much buy this in any woodworking store. I don't know if they sell at the local big box, mine doesn't, but it's great for very small shop. It is flexible, so if you need to move your tools around, this is the way to go. The downside of using flexible hose is it does create a lot of resistance, simply because there's a lot of ridges on the inside of the pipe and it's not smooth. Some study shows that you have 3 times the resistance in this flexible hose compared to, standard PVC pipe or metal pipe. So the benefit of this is, again, it is flexible, it is pretty cheap, but you don't want to use this if you have large tools that generates a lot of dust, or if you have a large shop. The next type of material that you typically see, and this is the material that I'll be using, is this. This is SDR35 pipe. It's a sanitary sewer pipe. You can get Schedule 40 PVC pipe. It's still plastic. It's pretty much the same thing. The only difference is SDR35 is a little bit thinner. The inside wall is a little bit thinner, so it's a little bit lighter than Schedule 40, I believe. And also in my area, SDR35 is cheaper than Schedule 40. The benefit of using plastic pipe over the flexible pipe is that the interior is smooth. So I don't know if you can see it, but it's a very smooth interior there. So it means that airflow will be a lot smoother on the inside. There'll be less turbulence, so that means less resistance compared to your flexible hose. The downside is it can get pretty heavy. Even though this is pretty light as is, it could get pretty heavy if you're installing this yourself, as well as it is more expensive than your flexible hose. One of the debates that I've seen when it comes to using any plastic pipe is whether or not there's a need to ground the pipe, because it does generate static electricity. Some would argue that the static charge could ignite and cause a fire in the ductwork, and it seems to be a very hot debate for some reason. I haven't heard of an issue or a situation where that has happened before, but if you're going to do this and if you're worried, you simply just have to wrap a grounding wire and then connect that to a screw in a metal box somewhere down the line, and that should take care of the static charge. Again, if you're worried about it, I'm not too worried about it. I haven't ran into a situation where I've seen or heard that a fire was caused by static charge, but that's that. The next typical material that you'll see would be metal. I don't have any metal pipe with me because I'm not using it. One thing to note is if you're going to use metal for your ductwork, going to the big box store and buying the sheet metal that you fold and crimp and seal up the edges it may not work for your dust collection system, especially if you're running a 2 or 3 or 5 horsepower motor. The suction on those motors could potentially collapse the sheet metal ductwork. One way of getting around it is to use spiral ducts. Spiral ducts could get pretty expensive. If you have the budget for spiral duct, then great, go ahead and use that. Also, there are companies out there who will size and create exact length metal ducts for your dust collection system. And they have these really cool fittings where it simply connects the two pipes with a little latch and it creates a really nice seal. The only downside of metal that I've seen is the cost. It just costs a lot of money to install a full metal system. SDR35 or PVC is going to be the best bang for your buck if you're in a small garage shop like mine. The next thing I want to talk about is fittings like these. This is a 45-degree angle 4-inch fitting for SDR35 pipe. If you're going to use plastic pipe, you can use this fitting right here. This black fitting is typically what you see at woodworking stores. Supposedly it's better than using PVC fittings, but you gotta make sure that these fittings will fit the actual SDR35 pipe. In some cases it doesn't. One way around it is just using tape to tape the seams together. And also keep in mind, this is typically more expensive than this. This was about $2 at the plumbing supply store. This was $6 at the woodworking store. So if you're just going to use SDR35, go ahead and go with these fittings. You'll save a little bit of money. They do come in two types in my area. This type does not have gaskets on the inside. There is another version that has a gasket on the inside where it's supposed to help with sealing the pipe together. I say just don't use the gasket. I bought the gasket versions for some of the fittings and it was horrible to use. Even after applying lubricant to the pipe, it was just a pain in the butt to use. And also it was more expensive too. So just go ahead and forget the gasket versions of these fittings and buy the plain welded version. You don't even have to weld these connections at all. The friction fit from the pipe and the fittings, it creates a really nice seal. So I would say just forget the gasket, get the regular cheaper one, and you'll be set to go. All right, this is where we get a little bit technical. I don't like to get technical, but I know that some of you guys out there really like the numbers. I don't really care about the numbers, but I want to show you pretty much what I'm getting for my dust collection system in terms of CFM, airflow, and all the sizing for my ductwork. This is a tool that I'll be using to measure the velocity of air running through my pipes. This is pretty cheap and you can purchase this on Amazon to run the test in your shop as well. In general, you're looking for 4,000 feet per minute for a woodworking shop running through the vertical pipes. Running through your horizontal ductwork, you're looking at maybe 3,000 feet per minute. Those calculations will determine whether or not you have enough air running through the system to pull out the larger chunks of wood that typically gets built up and could clog up your ductwork. If your dust collection system is giving you 4,000 feet per minute in terms of airspeed, you should be fine with the larger chunks and also with the fine dust, because with the fine dust, you don't need much velocity to carry that out of the system. It's the larger chunks that tend to settle down at the bottom of the ductwork that you're concerned about. So you gotta make sure that the duct size is appropriate to achieve those type of airflows.
So this is the chart that I kind of came up with so I can put in all of my numbers to show you guys what the results were. I'm not focusing on static pressure loss. I'm only focusing on CFM, velocity, as well as the cross-sectional area of the duct. I did the same test for the table saw, planer, bandsaw, and jointer like I did at the dust collector, which was to hold the meter in front of the opening and took a reading for the velocity. Plus or minus, 100 or so. I kind of just picked the middle one. If it was, for instance, as you saw from the dust collector, it was about maybe 5,200. The lowest was maybe like almost 5,000. So I just picked the middle number from there. Same thing with all the other tools. The first thing that I did was I went through the manufacturer spec book and I looked up the recommended CFM ratings for each of the tools. One thing to note here is this 12-inch jointer. It only says 400 based off the manufacturer recommendation. I think that's kind of low. I think in reality, you're going to need at least 500, 550 CFM. But that's just what I think. The Bandsaw Laguna has the Bandsaw rating at 1000. It didn't really specify whether one was more than the other, so I just split that 1000 in half for the top and the bottom, so each of them gets 500. The next column here shows you the actual connections that I'm using at the outlet port for the tools. The dust collector, you saw that it was an 8-inch flex hose. The length of it was 3 feet, so you can just take a look at these numbers here to let you guys kind of figure out what the flex hose runs that I had on my system. This column here is just taking the 8-inch, well in this case the 8-inch duct size, dividing it into 2 to give me the radius, and then dividing it by 12 to give me the calculation in feet instead of inches. So all of these are now in feet. The next column here is the cross-sectional area in square foot. If you don't know how to calculate the area of a circle, it's pi r square. So you take the radius, and it has to be in feet, and you just plug that number in, plug in pi, multiply it together, square it, and these are the numbers that you'll get. And then from there, you can take the velocity, you multiply it by the cross-sectional area, and it'll give you your CFM rating right here. One thing that stood out to me was the bandsaw. The bandsaw wasn't that far away from the Cyclone, and I'm not even getting enough CFM here to meet the requirements. So I think it has a lot to do with the weird shape that I had, that little U shape to connect to the 4-inch Ys. Again, I have to go through and kind of fix that and figure out, what is the best arrangement for it. But as you can see here, I'm a little bit under the CFM rating for the bandsaw. Yeah, so it's a little bit lower than what I expected it to be. The jointer, as you guys can see, I really think, this 400 is a little bit low. I think it should be more like, 600 to 700. But yeah, so that's pretty much the number here. This I forgot to mention that this column is the pretty much tells me if I'm above or below the recommended from the recommended CFM from the manufacturer. So these are above, this is way above, and then these are below. So that's pretty much it for the chart here. If you guys want to download this chart, I'll probably leave a link below so that you guys can plug in your own numbers and mess around with the formulas. That's pretty much the technical side. So if you care about the numbers, that's pretty much how you can figure it out for your own shop. So for my system, I took the concept of resistance and pretty much applied that to the design of the ductwork. To better understand resistance, I use the analogy of traffic. So if you can imagine your ductwork as a system of freeways and highways, imagine if you're trying to get onto the highway and you're at a right turn. What you'll have to do is you have to stop down significantly to maybe 10 miles an hour before you can make that turn onto the highway. On the other hand, let's say that right turn is more of a gradual loop. Let's say it's, you're turning at a 45-degree angle. You could probably maintain your speed as you get onto the highway, and you don't have to worry about slowing down or anything like that. The same thing applies with your dust collection system. You want to make sure that all of the turns are very gradual so that the air would flow smoothly through that transition and you won't deal with any turbulence at that corner. The same thing applies to all of the splits in the branch. I'm not going to use a 90-degree T. I'm going to use a Y fitting. The Y fitting will give me a more gradual airflow to connect to the main branch. On the other hand, let's say that right turn is more of a gradual loop. Let's say it's, you're turning at a 45-degree angle. You could probably maintain your speed as you get onto the highway, and you don't have to worry about slowing down or anything like that. The same thing applies with your dust collection system. You want to make sure that
all the turns are very gradual so that the air would flow smoothly through that transition and you won't deal with any turbulence at that corner. The same thing applies to all of the splits in the branch. I'm not going to use a 90-degree T. I'm going to use a Y fitting. The Y fitting will give me a more gradual airflow to connect to the main branch. Now that the numbers are clear, let's go over the layout for my entire system in the garage. I'll show you pretty much how I connected everything together and where things are currently at in my shop. All right, we'll first start at the dust collector itself. The inlet for my dust collector is 8 inches, so that's why I went ahead and used this 8-inch flex hose. The reason why I'm using a flex hose is simply because I need some mobility for my dust collector so I can move it in and out and access the back if I ever need to do any maintenance on it. This flex hose will give me that flexibility to do that. One thing to know about your dust collector is you want to maintain the size of the inlet of your dust collector as far as possible. That will help you overall with the efficiency of your dust collection system. If you're going to automatically reduce that down to, let's say, a 6 or a 4, it does create a lot more turbulence, especially at the inlet location. It'll create a lot of noise, more noise than you would want. When you reduce this down, you're essentially creating a lot of resistance for all of the ductwork that you'll be running in your shop. The first tool connected to my dust collection system is the bandsaw. And the bandsaw is connected to 2 ports, so you can see right here. They're both 4-inch ports connected with flexible hose. Again, I'm limiting all of the flexible hose to about less than 5 feet, so this will give me some movability with the bandsaw if I need to move it out of place to make longer cuts. I don't know if this will be the final location that I'll have the bandsaw in. Of course, with a small shop like this, things always get moved around. As the shop evolves and I bring in more tools, things are going to get moved around. So this connection here is not really ideal. Later on, once things are in the final location, I'll be able to figure this connection out and make it a little bit cleaner. One thing to note here is I installed this blast gate as a sort of like a main disconnect for the 6-inch branch that goes to the table saw and the planer. One of the complaints that a lot of people have about blast gates is they sometimes will forget to close a blast gate and the suction at the tool that they're using isn't so great. So by doing this, I don't have to run to the table saw if I ever forget. I simply just have to close this blast gate and it'll feed all the suction power to the jointer, which the jointer is probably the worst tool in the shop because it creates a whole bunch of sawdust. After using it for about a week and a half, I did notice that some of the blast gate locations, it is a little bit leaky. So what I did is I went back and siliconed the inside of that connection to make sure that it's properly sealed, and it's been working fine so far. The next tool connected to the dust collector is the jointer. It has a 5-inch outlet port for the dust shroud, and it's connected with this 5-inch flexible hose. I couldn't find a 6-inch to 5-inch reducer made out of SDR35 pipe, so I went ahead and just used this metal reducer and simply just tape the seams, and it works perfectly fine. All the tools in the shop has its own blast gate, so this one right here controls the suction to the jointer. Let's go with the jointer connection and I'll show you what I did there. So this is the connection for the jointer. I'm running the 5-inch flexible hose to the dust shroud, and what I noticed was that the dust shroud didn't really have a gasket around it, so there was some air leakage going through this edge here and also the bottom and the sides. What I ended up doing was just using some ductwork tape and taping all the seams to make sure that it's fully sealed, and it's been working fine so far. One recommendation that I had from a friend of mine who has the same jointer is he covered this bottom portion right here with a piece of plexiglass. It did help him with overall dust collection for this machine. So far it's been fine for me, but I did notice while running small boards, it did shoot out a little bit of chunks of wood on top of the bed. So if it does become an issue, I'm going to go ahead and also cover this with a piece of plexiglass, and hopefully that would alleviate some of the smaller chips that will shoot out of the tool. And the final connection I have in my dust collection system is the planer and the table saw. The first thing I want to talk about is this connection up here. The main branch line is 6 inches. I left a cap right there for future expansion. I currently don't know where I'm going to put the miter saw station as well as CNC router. once I figure that out, I can simply connect it to that cap and have the 6-inch pipe continue to the other side of the garage if I need to. With that 6-inch main, I'm going down to a 4-inch pipe right here, which splits to a 4-inch Y. One side is connected to the planer and the other side is connected to the table saw. And like the other tools, I am running flex duct from the actual power tool into the dust collector. Again, I'm limiting the flexible duct to less than 5 feet. And also, like the other tools, they also have their own blast gates. So if I'm running the dust collection system to this point, and if I'm not using the planer, I just simply have to close this port right here, and all of the suction will come down into the port for the table saw. And vice versa, if I'm not using the table saw, simply gotta close that port and open up the planer port. And that's pretty much it for my dust collection system. I do hope that you're able to take some key concepts here and apply it to your own shop. Again, this isn't supposed to be a full scientific calculation of dust collection system and sizing. This is really just me taking the key concepts of what I've learned and applying to my design. And the concepts that I applied to my system was very simple. I made sure that I didn't have any 90-degree bends for my fittings or wherever I needed to turn the pipe to another location. And I also limit the amount of flexible hose in my system to less than 5 feet or so. All right, so I'll leave the video there. If you did like the video, give me a thumbs up, please. And you want to hit that subscribe button so you can stay tuned for all the projects that I'll be doing in my shop. Until next time, this is Bao with Design Craft Workshop. See ya.